Hey there, Ravens. Welcome back. And now we're doing Charles's Law homework problems out of your packet. All right, let me get my pen up and running here. Okay, so Charles's Law homework problems. If a 45 milliliter sample, so that is a volume unit, so V1 is equal to 45.0 milliliters of a gas at temperature, so T1 is equal to 26.5 degrees C, and remember, anytime I write down degrees C, I add 273 to it immediately, and that gives me a temp of 299.5. And the unit is Kelvin, and it gets heated up, so that's going to be T2 is heated up to 55.2 degrees Celsius. And I'm going to add my 273 to it, and that gives me a new temp of 328.2. Okay, and I am looking for what is the new volume, and pressure is constant. Okay, so V2 is my unknown, and again I'm going to use V1 over T1 is equal to V2 over T2, and I want to isolate V2. So V2 is going to be my isolated variable. I'm going to be cross multiplying. So I know that the V1 and the T2 are going to be on top. And when I cross multiply here and divide by T1, I'll have T1 on the bottom over here. So now I can just plug in my variables. V1 is 45.0 milliliters. And my T2 is 328. And the decimal point's over here, not here. 328.2 kelvins divided by the initial T1, which is 299.5 kelvins. All right, my temperatures are all canceling because Kelvin cancels Kelvin. My answer will be in milliliters, and I did not get specified how to give the volume, so I'm going to leave it in milliliters. Don't change unless you're told to. And when I do the math, I come out with 49.3 milliliters. Do a does this make sense check. Okay, well, my temperature went up, so my volume should go up, and it did. All right, next one. A sample of neon gas occupies 266 milliliters, so that is a volume. So V1 is equal to 266 milliliters. And T1 temperature is going to be 25.2 degrees Celsius, and I'm going to add 273 to that right away so that I don't forget, and that becomes 298.2. And again, don't forget units are Kelvin. At what temperature of this sample of neon be reduced to half its original size, its initial size? So T2 is what I'm being asked to find. At what temperature? Okay, and if I want the volume to be reduced by half, that means V2 is going to be half of 266. So that'll be, volume would be 133 is going to be half of that in milliliters. Okay, and this time I'm looking for T2. So T2 2 is going to be equal, and I'm going to go back up here and look at this one right here for T2. T2 is going to have the top be V2 over T1, because when I cross multiply these, that's what I get. And for T2, when I then take the others and divide, I'm going to have V1 is going to end up at the bottom. Okay? All right. And so V1, or V2 is 133. So that's a 3. 133 ml. And T1 is 298.2 kelvins. And that I'm going to divide by V1, which is 266 ml. And when I do that, I end up with a temperature of 149.1 kelvins. So my volume decreased and my temperature decreased. So that's that one. Now if we look closer, this question had two parts. At what temperature would the volume of the sample of neon be doubled? So 266 times 2 would give us 532. So for this one over here, V2 is going to be 532. Okay, that would be the doubled volume. All right, so we have to do everything again. This time T2, V2 is 532 milliliters times T1, which is the 298.2 kelvins. And we're still going to be dividing by the 266. So we're basically using the same formula, okay? And that gives us milliliters. And so this answer comes out to be 590, that's a 9, 596.4 kelvins. And this time our volume went up, so our temperature went up. And that's it. All right, so next we're going to talk about Avogadro's law, and that will be our next presentation. So I'll see you soon.